.NET, we talked about this last time, I think. But here's a fun one where you reverse a .NET executable. So you download these samples, and you get a game from Flare-On. This is from the Flare CTF from years back. So when you run this thing, you have to run it, by the way. I had to run it in x64 debug. I don't know why. It's a .NET program and should just run in Windows 10, but it didn't work until I ran it in the debugger, and I didn't bother to figure out why. And so it just has this painting, this picture of Ross painting, and when you click the decode button, it changes his face to a dog, and it tries to decode the flag, but it's wrong. So your point is you have to figure out what this should be, and that would be the flag. And the point is .NET is real easy to read. So if you look in CFF Explorer, you'll see that this thing you're examining, called Challenge 1, is Portable Executable 32 .NET Assembly. And .NET is Microsoft's competitor with Java, so it is not compiled down to assembly code. It's compiled down to intermediate language called IL. And this IL spy program lets you see it, and you can just wander through the code in a tree-structured directory, and so you can find that button decode, and when you click on it, you can see high-level language here. This is C# source code, because the intermediate language goes directly to C#. You can just read real top-level short code. And here's the disassembly command here. All it's doing is taking the left 4 bits and moving them to the right half, and the right 4 bits and moving to the left half, so it's swapping the nibbles inside the byte, and then XORing with the fixed value 29. So that is the decoding routine, and it's doing that on data that came from the resources DAT secret. So this is the decoding algorithm, and DAT secret is just up here in resources. There it is, DAT secret. So all you have to do is, now you know how to do it, and now you go to DAT secret up here and you save it, you get the binary data, and all you have to do is decode it with Python. This is one standard technique. You just reproduce, and all you do is the same command in Python. Just read that file, do that, print the text, and you'll find the flag. So this is why it's incredibly easy to reverse engineer .NET, just like it's incredibly easy to reverse engineer Android apps that are written in Java, because the code is not really compiled. It's just compiled down to bytecode, and you can reverse it back to a high-level language and just read high-level source code. You practically have the source code. And there's a couple other another flag defined here from another file that's just a slightly modified one, and you'll have to get a different data process and go through a different decoding. All I did was take that and modify it a little bit. And then there's MemeCat, which is pretty fun. You run this one, and you'll find a game where you have to give it an arming code to shoot an enemy, and then another arming code to shoot another enemy, and you just have to know the arming codes. So all you have to do is examine the source code and go down to the fire button and look in here and read the code to find the arming codes. And one of them is just sitting there, and the next one is XORed with something again to make it a little bit tricky. But you can find the code here and deduce the right arming sequences to win the game. So that's the joy of .NET reversing, which is good to know. A lot of enterprise stuff is actually written in .NET. It is just like Android apps are all written in Java. It's open season for reverse engineer. Much, much easier than decompiling stuff with Ollie Debug and IDA Pro and all that. So a good thing to know. And that's all I wanted to show you.